Hello everyone, I'm Nika from nature conservation organisation Teen Defence United, or TAFU for short. TAFU's goal is to join the common objectives of young people and to promote personal responsibility towards nature. As a young geologist, I was very impressed by Cornish Lithium's research into finding a more sustainable and environmentally way of extracting lithium. Lithium is a key component in lithium-ion batteries, which are used in electric cars instead of fuel. Our guest today is Miss Lucy Crane, a senior geologist at Cornish Lithium. When I visited one of their sites, they referred to her as the brains of Cornish Lithium. She has joined me to tell us more about the important work Cornish Lithium is doing and has done in the past, what their plans are for the future, and most importantly, how lithium extraction in Cornwall will help conserve nature, and lastly, how we can help, which is most important. So I'll pass it over to her now. Lucy, over to you. You want to introduce yourself and Cornish Lithium?
Wonderful. Thank you, Nika, and thank you for asking me to be involved today. It's a real honour, and I think what you're doing is fantastic, and having these conversations that are so important, because, you know, there's that saying that everything we use in our daily lives has either been mined or grown, and so, you know, raw materials are vital to all of us, and it's sometimes missed out of this conversation about the energy transition and climate change is the fact that that's going to be really mineral intensive. So we've got to make sure that we're extracting these minerals in the most responsible way possible. So yeah, that's something I'm really, really keen on. So yeah, as Nika said, my name's Lucy. I'm a geologist by training. I studied geology at university, and then I did a master's in mining geology and have worked in mineral exploration ever since. And my role at Cornish Lithium, I've transitioned from the geology and exploration side of things, and my role is now ESG and sustainability, so the environmental side of things, making sure that we are doing this in the best possible way that we can, which is why it's so exciting to be talking to Nika about it today. So what are Cornish Lithium doing? We are exploring for lithium in Cornwall in the southwest of the UK, and we're looking to extract lithium from two different sources. One is from the granite rock itself. So southwest England is underlain by a big mass of lithium enriched granite. So we're looking at the potential to extract lithium from the granite itself. And then we're also looking at the potential to extract lithium from geothermal waters. So within this big mass of granite, there are big geological faults that have been there for millions of years. And there are deep groundwaters that circulate within these big geological faults. And these groundwaters, these geothermal waters, are relatively enriched in lithium compared to other groundwaters across the UK. So we've got the potential to use new technologies that allow us to just remove the lithium from water. And these waters are also warm. So if we can use that geothermal heat contained within the waters to, you know, help provide the heat for industry or towards our processing, then that could be a really neat, low impact way of actually extracting lithium. So shall I go into more detail about the kind of two different types of projects, perhaps?
Okay, yeah, sorry, I was muted. I was actually talking.
That's all right. There was a van in the background for me. So if we talk about the granite rock itself, so this big mass of granite that underlies all of southwest England is relatively enriched in lithium compared to other granites around the world. And there are kind of pockets of that granite that are more enriched in lithium than others. And in the centre of Cornwall, near a place called St Austell, they've been extracting china clay, or kaolin, for nearly 300 years. And that is a product that's produced as the granite weathers. So as the granite weathers and is broken down over time, it produces this clay mineral called kaolin. And kaolins are used in ceramics, it can be used in paints, in paper, it's used in so many different things that I didn't even know about. It's in toothpaste as well. And the St Austell region in Cornwall has been producing high quality kaolin for nearly 300 years. And it means that they extract it by open pit mining, so kind of like a quarry on the surface. So what we're looking to do is to go into one of these old quarries that they're no longer producing china clay from, and actually repurpose it and now extract lithium from that quarry. So it's not like we want to open a new open pit in the middle of Cornwall. I think that would be madness for lots of different reasons. But actually, if we can go into an old pit and now repurpose it to produce lithium, then actually that should help us minimize the environmental impacts associated with that extraction. It's already a pit, so if we can repurpose it, then there's the argument that perhaps you're being more efficient with that resource, and it ties into the circular economy and things like that. And we're looking to use a new technology, fairly new technology that's been developed by a company in Australia, which is called Lipidico, and it allows us to extract the lithium from the minerals in the granite and produce a product that's battery grade lithium. So it's ready to go straight into a battery. And that's really important because at the moment, the kind of supply chains for lithium are global. Lithium's produced in West Australia from hard rock deposits, so it might be produced in South America from these salty salar type brine deposits, but more often than not, at the mine sites, they'll just produce what's called a mineral concentrate. So they'll concentrate it up to a certain point, and then you have to ship it around the world to somewhere where you can do a second processing stage to kind of purify it into that high grade, high purification lithium that's ready to go into a cathode and then a battery, for example. Whereas we want to just do all of that on site in Cornwall. So it's shortening this global supply chain as well, which is really exciting. We're doing some work at the moment to try and understand what the kind of environmental benefits of using this processing technology might be, and also of having a UK-based supply chain for batteries rather than a global one, because we think that if you're producing stuff closer to home and not having to ship it around the world once or twice before it's ready to go into a car battery, then it sounds like that just makes sense. It should have less of an impact, but we want to be able to quantify that. So we're doing some work on life cycle assessments at the moment to try and actually allow us to quantify it. So that's our one project.
A couple of years back, I remember hearing a statistic about if you drove an electric car for a normal car for 10 years, it's the same as buying a new electric car. The same sort of amount of emissions. Do you think it's not going to be that bad now?
Yeah, so it's changing, and it's changing fairly quickly. So at the moment, the impacts because traditional cars, combustion engine cars, the supply chains for those are quite localized, and they're made out of lots of stainless steel and various other things, but they're not nearly as high tech as an electric car. So the amount of raw materials that have to go in, sorry, there's a lorry going past. The amount of raw materials that have to go into an electric car, you've got a whole variety, because you've got a lithium-ion battery, which involves lithium, manganese, nickel, cobalt. And so you've got a whole suite of different metals in electric cars that just aren't in a traditional car. So the impacts associated with producing that are higher than producing a traditional car engine. But obviously, as you drive a traditional car, you're emitting carbon the whole time. So the relative impacts go up and up and up over time. Whereas if you're driving an electric car, especially if you're then charging it with renewable energy, relative impacts go down and down and down. And there's lots of different studies out there that reckon that, the crossover point is something like once you've driven 21,000 kilometers, don't quote me on that, like it's around that. But because we're now starting to produce many more electric cars than we were even a few years ago, it means these supply chains are becoming more localized. So you're not having to ship quite as much all around the world as you were before. And relative impacts of producing it are coming down a bit. Oh, sorry, I don't know what they're doing outside. Can you hear me all right?
Yeah, I can hear you fine. Actually, I can't hear anything outside except for that.
Yeah, so that's why we use these life cycle assessments, because they allow you to compare the impacts across the whole lifespan of a product, don't they? So yeah, it's becoming less for electric cars, and I think it will come down even further.
Yeah.
But yeah, you can't get away from the fact that because you've got more materials and more variety of materials going into these electric cars, it is having a bigger impact when you first make them. But that's why recycling is going to become so important.
Yeah. Do you think, have you found any other metals in the waters that could be used for electric cars, like the other metals for the batteries, for example?
Oh, very good question. So we do think that there might be some other things in the water that we might be able to recover. So we should probably mention for people, so we're also looking at producing lithium from these geothermal waters. And there's a new technology that's been developed, which is called direct lithium extraction technology. And what that means is you can selectively remove just the lithium ions from the water. I'm just going to go into the next door room because this is really loud, but I'll keep talking. So you can selectively remove just the lithium ions from the water, and it's very different to what you might think of as traditional mining. So, you know, traditional mining is probably more like our hard rock project, where you're digging up rocks and then you're crushing them and then you're extracting the lithium in this case. This, what we're looking to do is put boreholes, so drill a hole from the surface down to one of these geological features where we know that there's water circulating. So that might be 1 kilometre down, it might be nearly 2 kilometres down. So we'll drill a borehole from the surface down to depth, pump those waters back up to the surface, and then put them through a processing plant where we just remove the lithium ions from the water. So they're in solution as lithium chloride, so they're there as a salt, and we can just remove that lithium chloride from the water, and then we can re-inject that water back down to depth. So it's very different to traditional mining, and yeah, we think it should have a really low impact compared to all other ways of extracting lithium that we've come across. And I've forgotten what your question was then. Is there anything else in the water? Yes. So the technology we're looking to just remove the lithium ions is very much specifically designed to just remove the lithium ions. But you might be able to tweak some of these technologies to do exactly that, see if there's anything else in the water and remove those. So there might be the potential for things such as rubidium and cesium within the water that you might be able to remove, maybe potassium as well. Potassium then can be used as a base for developing fertilizers, and that's important for agriculture. So we're looking into what these different options might be, but at the moment our kind of main focus is lithium. And then of course heat is a really significant byproduct.
Yeah. For the heat, you mentioned you would put cooler water back down into the granite. So could it have any effect on the granite?
Very good question. So we're doing a lot of research at the moment to see how best this might all work. But I think the really important thing in my mind is this granite is huge. It stretches all across southwest England, so for hundreds of kilometres, and it's probably at least 15 kilometres thick. And it's hot because it's a relatively hot rock compared to the rest of the rocks in the UK. Not nearly as hot as the rocks that you get in places such as Iceland, which is kind of on the edge of the plate margin and everything's bubbling up. So it's not as hot as that, but it's still pretty hot, and it's hotter than the rest of the UK. But geothermal energy, the reason that it's so exciting as a potential source of heat, and if you go hot enough to turn turbines, maybe geothermal power, is because really we're just scratching the surface of the Earth, and the Earth's massive. And so we're not too worried about depleting the kind of heat resource of Cornwall or the wider country through a few boreholes. However, what we are going to have to do is work out locally, because obviously these boreholes are going to be very local, whether that will have an impact over a kind of 10, 15, 20-year time period. So it might be that once you've drilled a borehole and you're pumping water out to extract the lithium, then putting the cold lithium depleted water back down, it might be that after 20 years locally, that borehole might not be much use anymore. But we're trying to do a lot of research at the moment to understand exactly that.
So how hot is it? What's the temperature approximately?
Very good question as well. So I think in the UK, the kind of typical geothermal gradient is about 35 degrees Celsius per kilometre. So for every kilometre that you go down beneath the surface, you're expecting the temperature to increase by about 35 degrees. It's slightly steeper than that here in the UK, or here in Cornwall, because of the granites. So we have had temperatures of about, I think we'd expect temperatures between 40 and 70 degrees Celsius at about 1,500 meters.
Oh wow.
So it's fairly warm. So it's not it's not, so for deep geothermal energy, which you might have come across in the UK or in Cornwall, they've had to drill down to, if you drill down to about 5 kilometres, you get temperatures of about 190 degrees Celsius. And what they're doing is then pumping those waters all the way up from 5 kilometres depth up to the surface. And because they're still boiling, when they get to the surface, they effectively go straight into steam. And you can use that steam to turn turbines and so generate electrical power. We're not drilling down to 5 kilometres because to do that, exactly, it's a very long way and you need massive drill rigs to do it. And it's a completely different game to drilling down to between 1 and 2 kilometres. So we'll expect temperatures of, if we're closer to 2 kilometres, maybe 70, 80 degrees Celsius. And so although it's not hot enough to generate geothermal power, it's hot enough for geothermal heat or warmth. And actually heating is one of the biggest carbon, heating our homes, heating our businesses is one of the biggest kind of reasons that we emit carbon in the UK. Something like 37% of all of our carbon emissions are associated with heating. And so we can help to provide a heat source for local industry or agriculture or even local homes, then it could be quite neat, because if we're going to be pumping up these waters anyway to extract the lithium, then it kind of makes sense to use that warmth too.
So would it be possible? So are you thinking of using the same water that you pumped up to go through the pipes in homes, or are you thinking of just transferring the heat to a different water or something?
The second one. So yeah, you probably transfer the heat. You can get these heat exchangers. So your water will come up in one pipe from depth, and then you'll have a pipe next to it, and then heat up the water in that pipe, and then that one will be the one that goes around, because we want to then extract the lithium from that cold water. So
How big is the drill?
That's a very good question. So the ones that we've used for the geothermal water exploration that we've done so far, the drill itself is probably about the size of a van.
Oh.
A van, and then it will have this big long mast that sticks up for 12 metres, no, 6 metres, somewhere between 6 and 12 metres. And then it drills with a diameter of roughly 10 centimetres. So you drill a hole that's about 10 centimetres wide that goes all the way down to over 1 kilometre. But it's not that big. It's not that big.
Yeah, well, something I wanted to ask.
So eventually when we come to doing this commercially, because obviously these have just been exploration boreholes, so we've had a theory that there's going to be warm water in a geological fault at depth. So we've drilled to see whether it's there. And now when it comes to doing this on a commercial scale, so actually extracting the lithium continuously and using the heat, we probably have to drill a slightly wider diameter, but it wouldn't be hugely different, just to allow you to put a bigger pump down the hole and pump that water up.
Would the water pump itself up, or would you have to add a pump?
We'd have to add a pump, to get the kind of flow rates that you'd need to make it worthwhile.
Will that, is it expensive? Obviously it's going to be some relatively expensive.
There's definitely going to be a cost involved with it, but a lot of the research work that we're doing now is to work out, so is it technically feasible, but then also what are the economics around it as well, because like you said, you've got to do it as long as it's going to make you money rather than cost you money.
Would it use up a lot of energy or something like that?
Again, that's something we're looking at. I think compared to a traditional mine to produce that same amount of lithium, perhaps not, but it's still going to be using definitely using energy. But I'd have to ask some other team members as to how much that might be.
And how much energy, approximately, do you think you're going to be making if it works?
So we're going to be producing heat energy, and how much of that, it massively depends on the kind of flow rate. So we are kind of expecting the temperatures to be somewhere within that range that we've just spoken about. So that's when it then matters how much fluid you're actually going to be pumping out and moving as to how much heat's going to be available. So all of these kind of technical engineering questions are being worked out by the moment. So our kind of research team's looking at those in a lot of detail.
What are the steps in your research to be completed? before?
Oh, wow. So first of all, there's the technical side of things. So we need to find, so if we're looking at the geothermal waters work programme, it's finding areas where we think that there's going to be permeable geological structures with lithium in them. So, and then you have to drill a borehole to see whether that permeable structure is where you think it is. And if it is, has it got warm water in it? And if it's got warm water in it, can you pump it to the surface and can you extract the heat and the lithium?
So is that like what you're doing in United Downs?
Yeah, exactly. So that's kind of been set up as a research facility to allow us to test that. And then once we've managed to pump some of these warm waters up to the surface, again using United Downs, we need to work out which technology, which direct lithium extraction technology is the one that's most suited to extract the lithium from these waters. So that research is well underway, and I think, you know, within the next 6 to 12 months we'll have probably decided on a technology that we're going to use to extract the lithium. And then it's not just extracting the lithium, you also need to concentrate it up, and we might use reverse osmosis for one of those steps, and it's putting that whole kind of, it's a big jigsaw puzzle, the processing flow sheet. So we need to work out, you know, what is the optimum way that we can do that, so it's most efficient and it's most economic as well. So those are the kind of technical things that have to be put in place. And then we also need to think about what might be the environmental impacts of it. What kind of permissions and permits do we need to get? What surveys do we need to do to understand the environmental baseline, so that we can then design our project so we minimize our impacts as far as possible? And for those that, you know, those residual impacts that are going to be left, how do we deal with those? How do we make sure that we are doing this in the best possible way? And the same for the social side of things as well, because we need the local communities around where we're going to be doing these projects to also benefit from them and to support us as well. So that is, once you've found the deposit, that's almost the easy, it's not the easy part at all, but there's so many other things to put in place too to actually bring it into commercial production.
Something else, yeah. 2 questions. How much area are you using so far, and how much do you think you're going to use in the future, and how much of that is new land to used?
Ooh, so that's a very difficult one for me to answer, so I'm going to answer it in 2 different ways. So because we've got 2 different projects, so for the hard rock project, I mentioned that we're looking to go into an existing China clay pit that's kind of come to the end of its life for producing China clay kaolin, and that has a footprint of, I'd have to look at a map, but let's say 800 meters by 300 meters wide for the pit, approximately.
Not as big as you can see from space.
Yeah, no, it's not nearly as big as some of the ones that you see. And you know, that footprint will be expanded slightly as we develop the project. But then associated with that, there's going to have to be a location for the processing plant as well. So where we'll actually extract the lithium from the rock. So then that will have a, you know, that will be a few hundred meters by a few hundred meters. But then you'll also need to have somewhere to put the waste, the tailings. And so again, those will be probably a couple of areas that are, you know, a few hundred meters by a few hundred meters wide, but those are all being decided at the moment.
Is the waste toxic or dangerous for the environment?
We're not planning for it to be. So there's different waste. So from the geothermal waters, there's very little waste because we're just removing the lithium ions from the water. And so there will be some wastes from that process, but we're expecting that to be really quite minimal. The waste, a lot of the waste is going to be the water that we've removed the lithium ions from. So we're hoping that, obviously subject to all the environmental permits and permissions and things like that, that we should hopefully be able to re-inject that back down into the ground. So yeah, it's not really waste, if that makes sense. We're just kind of moving it up to the surface, extracting the lithium, then putting it back down. Whereas for the hard rock project, when we extract the lithium, there's a few different processes that it has to go to. So the first step is the kind of mineral extraction process. So the lithium, kind of 3 main minerals in a granite. There's the quartz, the feldspars, and the mica minerals. and the microminerals are where the lithium is within the granite, we believe. So the first step is, once you've mined your granite rock, you need to separate out those lithium bearing minerals from the rest of the minerals. So that's a kind of physical concentration stage. So we want to effectively get rid of the rest of that. So some of that waste rock from that first part of the processing, we're hoping to use as aggregates. So maybe sell it for, whatever you want to use aggregates for, sand, gravel, all those kind of things. So we're hoping that we can turn as much of the waste into actual sellable products, because we want to minimize what we've got to get rid of, because of, it makes environmental sense to minimize your waste as much as possible, but it also makes economic sense too. And so then once you've extracted your lithium bearing microminerals, you then need to get the lithium out of those. So then it goes into kind of stage 2 of the processing, and that's a hydrometallurgical stage. So it will use different reagents and things like that. So some of that waste we may have to dispose of more carefully, but all of the kind of characterization of what we're going to produce is being carried out at the moment. And we're developing our project in the UK, and we've got very high standards here, so everything's got to be.
I didn't hear your last sentence, it broke up.
So we're developing this project in the UK, so we've got to do everything to really high, some of the world's highest environmental standards anyway. So whatever we're disposing of will have to be disposed of really, really safely. So at the moment, we're doing test work to characterize what those waste streams might look like and how much there will be of it. And from that, we'll then have a plan as to how we can safely dispose of anything that, we can't make a second product out of.
How deep is the open pit going to be?
Oh, you're really testing me now, Nika. So I think it's already 30 meters deep, I think. And perhaps it might go up to 100 meters deeper. So again, I'd have to check with the technical team, but it's going to be small on the global scale of open pits, definitely.
I've seen pictures of some that are like kilometers deep.
Some of them are huge. When I was doing my master's, I went on a trip to West Australia. We did a field trip to West Australia, and we went to a place called the Super Pit in Kalgoorlie, which is it's just blows your mind. I think it's the biggest man-made infrastructure in the world. It's just this giant kilometers long, like you were saying, kilometers long, hundreds of meters deep. It's mad.
Wow.
Yeah, so nothing like that. It's going to be much smaller.
Well, I wanted to ask if, when you do go commercially, are you planning to use some of your profit to, use some of the profit to build up nature reserves or somewhere, so it will equal out in a way?
Yeah, no, that's a really good question. So when we start producing lithium commercially, absolutely we want to do good things, but actually, because of the fact we're in the UK and also we want to do things properly, one of the pieces of work that we're doing at the moment is working out exactly what will happen when the mine comes to the end of its life. How will we close it? How will we rehabilitate it? And how will we make space for nature and, return it back to nature? And in the UK, they're bringing in a piece of legislation that means that you have to deliver at least 10% biodiversity net gain from projects. So we will have to create at least 10% more habitat than we've used. And actually, it may well be higher than that, what we actually end up doing. So as well as the fact that legally we're going to have to do that, we really want to make sure that we can create these habitats. So one of around our hard rock project, around the granite project, there's a kind of geological site of special scientific interest. So one of the things we'd like to do in the near term, at the moment it's all overgrown with brambles and you can't see it and you can't really get into it. But what we're looking at doing is whether we can help with the management of that and create some more habitats within that space. And, you know, that's just on a small scale at the moment. But yeah, and that's why these baseline surveys, these baseline ecological and environmental surveys that we're doing are so important, because we need to understand what's currently there, how we can design our projects to have the smallest impact possible at the moment, but then also when we close it, how can we design it to maximize the kind of local habitats around there that are suited to that place. So yes is the answer, absolutely.
How, I don't know, I'd say, like, how big, not how big, even I forgot half my question now. Doesn't matter, different question. How, oh yeah. Oh yeah, what I want to ask, like, you said that shortening the supply chain is going to help a lot. Is there any statistics yet? I know there probably isn't, is there?
Yeah, there's a lot of people kind of looking into the impacts of these global supply chains. And actually, the UK government very recently released a strategy on critical minerals and what we're going to do about them, because they've realised now, as we all know, that minerals are really important. And if, right as you said in the introduction here, if we want to have low carbon technologies like electric vehicles and things like that, we need materials to make them out of. And if we're going to be making them out of materials, then we need to make sure that we're extracting those materials in the most responsible way, because there's no point driving an electric car and feeling really good about, you know, you're minimizing your impact on the planet if actually the impact of creating that electric car has had a much worse impact than if you just carried on driving your old car. So governments are starting to wake up to having oversight of what their supply chains look like. And part of that is from a kind of political standpoint. They want to have control over things. And, you know, the war in Ukraine, for example, has really disrupted a lot of these supply chains. But part of it's also because if you know where everything's coming from, then you can start to measure what the environmental impacts are of your supply chains. So although I don't have any statistics right to hand at the moment, it's becoming so much more important to loads and loads of countries all around the globe, because, you know, we need to start taking responsibility for all of these things that we're using and consuming.
Yeah. What was it? Going back to the beginning in a way, we didn't ask how was Cornish Lithium founded?
How was it founded?
Yeah, like who founded it? Why?
So it was founded in 2016 by our CEO, a gentleman called Jeremy Rathall. So he's a mining engineer by training, and he studied at the Camborne School of Mines, which is the kind of famous mining school down here in Cornwall. And so he's always had links down here ever since then. And he worked as an investment banker for quite a long time and funded mines all around the world. And he saw that this energy transition was coming and that raw material is going to play a really important role in it. And exactly as you said at the start, electric cars are going to play a really big part in this energy transition. And lithium in particular is a really important input into those electric cars. So he had heard that there might be some lithium in Cornwall historically. And so I think he just started Googling it. And he found some information online that suggested, yes, there was lithium in Cornwall. And so it gave him enough confidence to start the company. And then he got some funding for it and started to sign up mineral rights. So we've got the rights to explore for lithium across lots and lots of Cornwall now. And so, yeah, then a year later, started to pull together a technical team to actually start the exploration. So that's when I came on board as a geologist. And yeah, we've now got a team of, I think about there's 50 or 60 of us. And we found that there is lithium, and there's lithium in these two different types. And yeah, we're working towards now how do we move to actually developing these projects and extracting it in the most responsible way.
Yeah, well, you said permits. Do you have offshore permits as well to have a look at?
Yeah, so we've got some exploration permits from the Crown Estate. So the Crown Estate own the kind of offshore area in the UK, and we've got permission from them to explore for lithium in geothermal waters across 4 areas offshore of Cornwall. And that's because these geothermal waters that we talked about earlier, you find them within these big permeable geological faults, these kind of naturally occurring cracks and fractures in the Earth's crust. And that's where we've got this, there's enough space for these waters to circulate. And we know that these geological faults are where you can find the water onshore. And actually we can see in kind of seafloor data, bathymetry data, that these geological faults can extend offshore for 5, 10, 20 kilometres. And so our hypothesis is that if you've got lithium enriched geothermal waters at depth in these faults onshore, why wouldn't they also be there offshore? But we're doing desk-based research for that at the moment, but we've got to prove the concept onshore first. So we'd be years away from doing any actual physical exploration, but desk studies suggest that it might be there. And so we're lucky enough that we've got permission to start looking, but we've got to do it onshore first.
Yeah. Wanted to ask, oh yeah, would a borehole would it also work underwater? That sounds weird.
Yeah, I think so. So there's a lot of people who do drilling offshore into the seabed, and you know, they used to do it a lot for oil and gas. For fixed offshore wind, they have to drill the bottom of the turbines to the seafloor and attach them like that. So there's much smarter people than I who know how to do it, and it is possible, to do it and try and minimise the environmental impact from it as well. Because you're right, it would be drilling boreholes to access those waters. So yeah, it's possible.
Cool. Sounds very interesting. Also a bit confusing at some points. Just trying to remember what my last question was. I kept writing them down, but not all of them. So
yes, well, yesterday we also, so the question about geology and nature, and why is geology a good basis for nature? I could talk about that if you like.
Yeah, that'd be good. Yeah.
So I think as a geologist, you have a really good appreciation for how the physical world works. And a big part of learning about geology is also paleontology and learning about evolution and all of those fun things, and seeing how everything's evolved and learning about mass extinction events. And so I think that as a geologist, our training in understanding and recognizing all of these things makes us really, you know, we've got the skills that are going to be really vital in this energy transition, because we want to understand how to find resources within the earth. We need to find out how we can extract them in the most environmentally responsible way, but we also need to understand how to recognize things when they aren't going well as well. And I think the way that you think as a geologist, you can take these big data sets that all come from different sources and you can assimilate them in your mind and come up with some kind of theory and some solution. It's really, really valuable. And the link between geology and nature is so strong. The reason that we want to have this energy transition, stop burning fossil fuels, is because we want to have a safe environment for future generations. And part of that means we need a thriving natural world as well. And they're so intertwined. And so I think geologists are really key to helping preserve not only our current environment, but also our future environment too.
Yeah, it's amazing how in geology we can just not making up, but finding theories of how it works and things we will never be able to see, like convection curves. It's just crazy.
Yeah.
So it's bound to be very helpful for the future.
Absolutely.
Yeah, I think, it's amazing, really. So also it's amazing how we wouldn't even have buildings if we didn't have geology.
Well, exactly. You'd have to go back to before the Stone Age, wouldn't you?
No. I wanted to ask, why is it enriched in Cornwall with lithium rather than anywhere else?
So lithium itself isn't actually that rare as an element, but finding it in places where it's kind of concentrated enough to make it economically viable to actually bother extracting it, that's something is quite rare. So in Cornwall, the source of the lithium is this big mass of granite that underlies the county. And where the reason that is lithium enriched is probably because it formed, the precursor to granite is its melted rocks, isn't it? Yeah. And so there must have been some kind of lithium enriched precursor, I imagine. But what's interesting in Cornwall is that it's kind of bulk enrichment throughout the granite, rather than in other parts of the world where you've got lithium enrichment. It tends to be in seams or pegmatites, and you get these kind of narrow, really rich veins of mineralization, whereas in Cornwall it's kind of disseminated throughout the bulk of the rock, and there's pockets of that granite that are more enriched in lithium than other. And it's, to tell me if I'm going into too much detail, but the granite that kind of underlies southwest England was intruded over about a 20 million year period. I think it's from about 290 to 270 million years ago. And different parts of it kind of were intruded at different times. And the stuff that was intruded right at the end, so the last stuff to be melted, the last stuff that was left as a melt and then eventually intruded and cooled and solidified, it's those last bits that are actually more enriched in lithium than others. Well, so it's those later pockets of granite that we're looking for.
So would that also be the stuff on the bottom of the chamber?
Oh, depends, I think. There's kind of different kind of shoots of it going up, I think. So something that our geological team are looking to get a better understanding of is exactly that, like where is it at the margins, is it at the roof, is it at the, so it's something our geological team is definitely looking into to get a better understanding of, so that we can understand that grade distribution a bit more.
Do you think that there's going to be overall, like, do you think it's economical to mine it everywhere, like throughout the granite, or is it in very small pockets?
Small pockets, I think, definitely. Small pockets, especially from the hard rock. From the geothermal waters, we think that might be more widespread, just because there's these geological faults cutting across everywhere in Cornwall. And we think it's quite a big plumbing system. We think that a lot of those are all interconnected. So you could probably do lithium from geothermal waters across quite wide parts of the county. But for the hard rock, where it's in the granite itself, we think it's kind of these limited pockets that are probably the ones that are enriched.
Yeah. Do you have a concentration number by any chance?
Not that we've published, I'm afraid, not for the geothermal waters. But, they're not numbers that you'd see and think, wow, that's really high. So for the geothermal waters, the number that we have published is we took some samples from the Deep Geothermal Project. So from water that was pumped up from 5 kilometres depth, we took samples of that at the top, and that has about 260 parts per million lithium in it, or milligrams per litre. So yeah, less than a gram per litre. So doesn't sound like much, and it's not a huge amount, but it is relatively enriched compared to other waters. And then for the hard rock project, the lithium's there at around, I think it's around 0.1%. So again, it's fairly low, which is why it's so important that we can produce things like aggregates and minimize the amount of waste rock as far as possible.
Do you think if in a couple of years the technology gets better, do you think it would be more economical to mine other places as well in Cornwall?
Potentially. Yeah. And the other thing is that as demand for lithium increases across the world, the price of it goes up. So people are willing to pay more for it if there's less of it around. And so if the price of it goes up, then things that were too expensive to extract before might actually become feasible to extract. So that's where the kind of economics of these projects is also really important to understand.
Yeah. I want to ask, where are you getting, is your funding from the government or?
Various different things. So we have had some government funding through grants, and those are mostly to allow us to do specific projects that are quite innovative. So we might partner with a university or some other industry partners, and we'll do a specific project. So we might be looking at the potential to produce lithium from China clay waste, for example. That's one project that was funded by the government recently. But a lot of the funding for the company is from private investors at the moment. So private equity firms or private investors.
Yeah. You mentioned university. Do you train any people who have just come out of undergraduate or?
Yeah, we do. So we have a number of internships. So people who are at university or just finished university, we try and do as many internships as we are possibly able to. So people will come and join us for 2 weeks or 2 months and do a project with us on something specific, and gives them experience working for a company, but also gives us some really useful research sometimes too.
Yeah, I remember can't remember her name, but the other lady who was there when I visited United Downs, she was, I think,
Kira.
Yeah, I think so. Yeah. Mid-year from postgraduate degree, was it? I can't remember.
Yeah, she's doing an internship as a break from her PhD, I think.
PhD, yeah, that's what it was.
Yeah,
Wow,
she's wonderful.
it's amazing, really, how you can train and everything.
Yeah.
Do you think that there's more? Well, it's a weird sort of question, really. How to phrase it? Like, is it more important to have like new technology and resources, or are old resources also very important?
Both, I think. New technology is really important because it can help us, I keep going back to this word, more efficient, but it can help us do things more efficiently. So new technologies might allow us to explore for and find mineral deposits that we might not have otherwise found. So using satellite technology, satellite imagery, you can use machine learning and AI to help vector in on targets, perhaps. We can also use new technology to allow us to extract things such as lithium from resource or deposit types that previously no one's extracted lithium from commercially. So geothermal waters is an example of that. There's still no one producing lithium commercially from geothermal waters, but it's these new technologies that have really been developed rapidly over the last few years that look like it could well be possible now.
Yeah.
And so new technology is super important, but so is having that kind of traditional grounding in how to find things, what geology is, and what these deposits, what deposits might look like.
Yeah. So it broke up in the last ending, but I think I heard everything. What did I say? Yeah. Do you think it's a good time to get an electric car then, or do you think it's better to wait for Cornish Lithium to get into business?
I think it's a good time. I'd love to have an electric car if I could. One day soon, definitely.
It's so expensive, which is the problem, and there's none on the second-hand market yet.
I think that's it. And yeah, but again, technology is developing so rapidly that they're becoming faster and faster to charge. The infrastructure to charge them is becoming so much more widespread, and also, yeah, they are going to become cheaper as well, I think.
Hopefully. They're also so quiet, which is dangerous, but also very good.
Yeah, I think they might have to. Yeah, they need to put some noise in them sometimes, because you listen for crossing the road, don't you?
Yeah, you listen more than you look, and then there's a car. I didn't know that coming.
Yeah, sneaking up on you.
But it's very good for the environment, which is a good thing.
Yeah, definitely.
Do you think there's a possibility of more like bigger vehicles being also more electric? Like,
yeah, I think that a lot of research is going into that. I think it might be that for really big vehicles, they're talking about hydrogen power instead.
Yeah, I saw that.
Because the batteries would just have to be so big for electric ones that they become really heavy, and because it's so heavy, I think it is counterintuitive then. So I've heard talk that they're looking at hydrogen power for, big machinery and maybe big lorries and stuff like that.
How does that work? Is it environmentally friendly? How does it work?
It can be. It depends how you make the hydrogen. So you can make the hydrogen either from a kind of hydrocarbon, fossil fuel precursor, or you can make it from electrolysis of water. But that's really energy intensive. So there's no real good way of making it in an environmentally friendly way at the moment.
Yeah, unless you use.
I say that there are, but again, not on a big scale. So
yeah. Unless you use complete renewable energy, which is hard to get.
Yeah, exactly. So there's a long way to go. There's lots of exciting things that it feels like we're on the edge of them all happening, doesn't it?
Yeah, it's quite amazing, really, how so many different ways that geology is coming into literally being applied in day-to-day life. Yeah, I'm not sure if I've got any more questions. Anything you'd like to say?
But just thank you so much for asking me along to come and have a chat. It's been really lovely speaking to you. And I think it's a really exciting time to be a geologist, and we need people who care about the environment and who want to look after the planet to be involved in industries like mining, because it might not be the traditional industry that people think of if they care about the environment, whereas actually it's so important that we have good people coming into it. So yeah,
it's very important to love both geology and the environment, otherwise it sort of goes on to a sort of random weirdness. If you get both together, it's a nice path.
Absolutely.
Well then, thank you, Lucy, for taking the time to join us. We know how busy you are, so thank you very much. It was amazing to hear about what you guys are doing at Cornish Lithium and how that helps to conserve our environment. Thank you all for watching and staying tuned while I was trying to word my questions. I hope that you will learn from this video that there is a better way forward. See you all next time. Bye!